Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC B1836, indicates a fault in the power seat position sensor circuit in the Honda Odyssey models from 2011 to 2017. This error typically signifies a short occurrence within the power seat system, leading to incorrect signals being sent regarding the seat's position, which can compromise the functionality of the power seat adjustments. The power seat control unit plays a crucial role here by managing adjustments based on input from the position sensors located in the seat's mechanisms. If this system malfunctions, it could lead to an inability to adjust the seat properly, affecting driver and passenger comfort and safety. You'll often find the power seat control unit located under the seat. However, the exact wiring and connectors might be dispersed and require detailed tracing to fully understand the circuit at fault. Getting a handle on this code requires systematic troubleshooting to identify issues in the wiring and connectors that feed power to the seat adjustment functions. The power seat control unit is at the heart of this DTC B1836 error, responsible for managing signals based on sensor feedback. It is collaboratively worked with various position sensors located throughout the seat mechanisms. These include sensors for recline, up-down movement, and the slide motor that accommodates seat adjustments. The components directly impacted by this error are the power seat control unit and these multiple position sensors situated directly under the seat. When the seat adjustment switch is activated, the control unit interprets the signals from these sensors to command the seat's movement. If there's an issue like a short in the wiring, the entire system's functionality is compromised. Understanding the layout and functionality of these components is pivotal when addressing the underlying problems linked to DTC B1836. When diagnosing DTC B1836, several possible causes must be considered. One of the most common issues is a short to ground within the wiring that powers the seat position sensor and control unit. This could lead to unintended signals being sent or received by the system, resulting in erratic seat behavior or complete failure. Loose or corroded connections could also be a culprit, preventing reliable communication between the power seat control unit and its sensors. Finally, a malfunctioning power seat control unit itself could lead to this DTC being triggered. Understanding these possible causes ensures that technicians can effectively navigate the troubleshooting process for a reliable resolution. Symptoms associated with DTC B1836 primarily revolve around difficulties in operating the power seat. Drivers may experience a complete lack of response when attempting to adjust the seat position, which can be frustrating and dangerous during driving. In some cases, the seat may respond erratically, moving unexpectedly or only responding partially to user inputs. This might include a failure to adjust the seat forward or backward while the recline function works normally, or vice versa. All these symptoms point toward a malfunction within the power seat position sensor circuit, necessitating a thorough check of all associated components and wiring to pinpoint the exact issue that triggers the DTC. To begin the troubleshooting process for DTC B1836, it is essential first to clear the existing diagnostic trouble codes using the Honda Diagnostic System, HDS. This specialized tool allows technicians to reset any stored codes and prepare the system for a fresh run test. Performing this task can help in identifying whether the error is persistent or intermittent. By resetting the codes, you provide an opportunity for the vehicle's onboard systems to recalibrate. It is critical to execute the following steps methodically to ensure all data is accurately captured for the next procedures. After clearing the DTCs, the next step involves manipulating the ignition switch. First, turn the ignition switch to the lock position, which ensures that all electrical systems are powered down and reset. Then, switch it back to the on position to activate the electrical systems again. This step is crucial as it prepares the vehicle for the subsequent actions involving the power seat adjustment switch. You enable the power seat system to initiate a self-check while allowing any residual error codes to reappear for diagnosis. This preparatory phase is essential for aligning the troubleshooting efforts with vehicle protocols. In this troubleshooting step, you'll operate the power seat adjustment switch in all directions. This action should be performed for more than 1 second in each direction. This comprehensive testing allows for an evaluation of whether the seat responds appropriately in all movement modalities, including forward, backward, upward, and downward adjustments. As you conduct this test, keep an eye out for any operational inconsistencies or diagnostic light indicators that may activate. This step is vital for feeding subsequent diagnostics with real-time functionality data about the seat adjustments and providing insight into whether DTC B1836 reappears during this testing phase. After actively testing the power seat functionality, the focus shifts back to using the Honda Diagnostic System HDS once again to check for any DTCs. It is crucial to determine whether DTC B1836 has been re-triggered after performing the seat operations. If the code appears again, it indicates that the short circuit or malfunction has not been resolved. If it does not reappear, it may suggest a possible intermittent failure, implying the system could be functioning correctly at that moment. However, technicians should remain vigilant and check for loose or poor connections while continuing with the diagnosis if the error does re-emerge, as these can often lead to erratic performance. In this step, once you've confirmed the reappearance of DTC B1836, you need to turn the ignition switch back to the lock position. Ensuring that the ignition is off is a critical safety measure while performing this next troubleshooting phase, especially when disconnecting electrical connectors. This will help avoid any electrical shorts or inadvertent signals that could potentially complicate diagnostics. Once the ignition is locked, prepare to disconnect several connectors associated with the power seat mechanism to facilitate a more in-depth examination. This process sets the stage for directly inspecting components and wires involved in the sensor circuit. The next pivotal action involves disconnecting various connectors linked to the power seat control unit and its associated position sensors. You will disconnect several connectors, including the power seat control unit connector B40P, the slide motor position sensor connector, and several up-down motor position sensor connectors. Performing these disconnections is crucial for isolating the electrical components you will be testing in the next steps. It allows you to check each individual component for continuity issues, identifying if any of the wires or connectors are faulty or shorted. This step is instrumental in narrowing down the source of the fault pertaining to DTC B1836. In this step, you will be checking for continuity between the body ground and the power seat control unit connector B40P at terminal number 6. Continuity testing is critical in determining if there is an unintended electrical path within the circuit that could indicate a short to ground. A successful continuity reading implies that the connection is intact, while a failure to show continuity suggests that further investigation is warranted in the wiring, indicating a possible short somewhere in the circuit. If continuity is present, your focus will shift to repairing the short in the wiring. This diagnostic step emphasizes the importance of understanding the circuit layout and monitoring electrical paths for efficient troubleshooting. The final troubleshooting step involves checking continuity again, this time between the body ground of the motor itself and the slide motor position sensor connector at terminal number 4. Conducting this test helps to evaluate whether the slide motor is receiving proper ground, a necessity for its functionality. If continuity is detected, it confirms that this particular connection is sound. Conversely, if there is no continuity, it indicates the need for additional investigation into the motor or the associated wiring that connects it to the ground. Ensuring proper grounding is essential in harnessing the intended operations of the power seat systems, validating that all components can correctly receive their operational signals. After following through the complete troubleshooting steps for DTC B1836, it is essential to conduct a final verification of all repairs made. Begin with a thorough recheck of all connectors and wiring to ensure that every connection is secure and installed correctly. Following this, test the power seat to verify that it operates smoothly in all directions without triggering the Diagnostic Trouble Code again. Confirming that the DTC is cleared validates the successful resolution of the original issue. This wrap-up step is essential for ensuring that the system is returned to optimal functionality and that no lingering issues remain. To mitigate the chances of future occurrences of DTC B1836, engaging in preventive maintenance is vital. Regular inspections of the connectors associated with the power seat system can help identify potential issues like corrosion or loose connections before they become problems. It is critical to keep the wiring harness clean and insulated, as exposure to moisture or dirt can lead to shorts or unexpected behavior. Maintaining dielectric grease on terminals can protect them from corrosion and ensure good electrical contact. Additionally, performing routine diagnostic checks can help catch anomalies early before they escalate into more significant failures, ensuring that the power seat functions as intended over time. In conclusion, DTC B1836, which signifies a power seat position sensor circuit short, requires careful attention to detail during troubleshooting. Understanding the intricacies involved with the power seat control unit and the various interconnected position sensors is essential. By following a structured approach, from error diagnosis to detailed testing of connectors and wiring, technicians can accurately identify and rectify issues affecting the seat's functionality. Symptoms like improper seat adjustments underscore the importance of resolving this DTC promptly. Through rigorous testing and preventive maintenance practices, future issues can be forestalled, ensuring smooth and reliable operation for the vehicle's power seating system. Please like and subscribe to the channel. See you next time.